Hello Year 11s, I hope you're all doing well. What I'm doing in this next video is I'm going to go through some of the questions that were submitted to the Google Classroom or via the Google form. This first video is going to look at questions from that solving simultaneous equations set of questions. And so have a look at this if you have any particular questions you wanted to have a look at. I'm also going to try and annotate so that you can click in the video just to give you timestamps of when different questions are. So let's have a look at these questions. I'm going to full screen myself. Okay, the first one was submitted to us by Alex in the Google Classroom. So in this question, you have 4x minus 5y is equal to 2 for our first equation, and we've got x plus 10y is equal to 41. And we wanted to solve that using substitution. So this one specifically said use substitution method. So we wanted to use substitution method. Now, if you remember in the notes and also in the video, I said that for the substitution method, what you want to do is write one of your equations in the form with one of the prenumerals as a subject, or it has to be in the form x is equal to something or y is equal to something. And that's what you want to do. So let's have a look at our two equations here. So I've got 4x minus 5y is equal to 2. And I've got x plus 10y is equal to 41. Now, if you have a look at these two, the one that I'm going to try and rearrange is the second one. So I'm going to rearrange equation number 2. The reason being is if you have a look in equation number 2, my x term doesn't have a coefficient. That's already nice and lovely in this kind of form, x, where I have x by itself. So all I need to do is just move this y term over here to the other side and I've got what I want. So I'm going to do exactly that. So I'm going to have x on the one side by itself. I'm going to rewrite this, it's a little bit messy. X all on itself by itself on one side, and that's equal to, when I move that 10y to the other side, it becomes minus 10y. So here I'm going to have 41 minus 10y. Okay, so that's rearranging the equation number 2 first. So this is I'm going to rename this equation. I'm going to call it 2a because I kind of worked off of equation 2 to get to this second equation. Okay, now that I've done that, what do I do with the substitution method? With the substitution method, I'm going to substitute my x is equal to 41 minus 10y back into the first equation. So let's do that. So what I'm going to do is I'm going to go sub 2a into number 1. So I'm substituting this new equation that I've created back into my first equation. So here I'm going to have 4 times, and I'm going to do this in different color just so we can see it. So 4 times 41 minus 10y minus 5y is equal to 2. That's what I get when I substitute my equation 2a back into 1. So I'm substituting this whole thing that I'm going to put in a red box. I'm substituting this into this first equation, and in particular into this spot where I see x. So I've substituted that in. Great. Now that I've done that, what do I need to do? Well, if we're trying to solve this equation, I probably want to get rid of those brackets. So I'll probably want to get rid of those brackets so it makes it a little bit easier to work with. So I'm going to expand it out. So I'm going to do 4 times 41 and then 4 times minus 10y. So here I'm going to get 164 minus 40y minus 5y is equal to 2. Okay, I'm going to combine all my y terms on the left-hand side. So I'm going to get negative 45y is equal to, now this number over here, I don't want it over here. I want to move it to the other side. So if I move it to the other side, I subtract it. And so what I'm going to get is 2 minus 164, which I think gets me negative 162. Negative 162. So if I'm trying to solve this, what do I do then? Well, I divide both sides by negative 45. So here I'm going to go y is equal to negative 162 divided by negative 45. Let me just check what that is. That'll give me, as a fraction, it will actually give me 18 over 5 when it's simplified. Usually, if you can't do those big division steps, what I like doing is just put it in the calculator. Nice and easy. We can get that number really quickly and you don't have to check what it is. Okay, cool. So we've got this fraction here. We've got y is equal to 18 over 5. Now that I've done that, what do I need to do for my final step? I need to find the value of x. So here I'm going to go, okay, so let's sub y is equal to 18 over 5 into And you can pick any of your equations. I'm going to pick 2a because we've already created an equation where we have x on one side by itself and makes it a lot easier for us to work with. So I'm going to go sub into 2a. So here I'm going to get x is equal to 41 minus, what is it, 10y. So I'm just going to replace the y value of 18 over 5. And when this all simplifies, I think you end up getting, let me just check, x is equal to 5. And so the final answer is, therefore, x is equal to 5 and y is equal to 18 over 5. So for this first example, so question 3G, that's what we do. When we substitute, we use the substitution method. We first need to write one of our equations in the form of, well, I need to change the subject, so I need to write it in this form, x is equal to or y is equal to. So often this might require you to do this rearranging step. Then once we've done that, we substitute that value into another one of our equations, in particular the one that we haven't touched yet. And then once we've done that, we can, we get one of our, we sub it in to our first one. And then once we've done that, we find a value for y, our first pronumeral, and then we sub that back into our second one. Now, this question in particular asks you to do the substitution method. I'm going to actually show you, if I was to do this question on my own without any prompts, I would use the elimination method. The reason being is because I'm just going to write the equations over here again. I'm going to just copy and paste this so that I can work with it. I'm going to copy and I'm going to paste it over here. Okay. Well, if I was to solve this without any prompts, I would probably use the elimination method. The reason being is because when you do the elimination method, all you do is you eliminate one of your pronumerals first, and then you solve for the other one and do very similar steps to the other one. Now, if you have a look here, when I do the elimination method, I want to check that the magnitude of the coefficient. So it's just looking at the number before the pronumeral, so the magnitude of the coefficients. I just want to make sure that I've got a pair that matches up. If you have a look here, both of them don't actually match up. But I can do something really easily to make them match up. If you have a look at the second circle that I've drawn, I've got 5 and 10. What's a number that 5 and 10 both go into? Well, 5 and 10 both go into 10. 5 times 2 gives me 10, and 10 times 1 gives me 10. So here, what I can do is this first equation, I'm going to write here, I'm going to change it up as well. So for this first one, if you're doing the elimination method, I'm going to multiply equation number 1 by 2. And by doing so, I'll get the coefficient of y as 10. So here I'm going to have 4x. Oh, actually, when I multiply by 2, I have to multiply every term. So it's not going to be 4x. It's actually going to be 2 times 4x, which is 8x minus 10y is equal to 4. And I'm going to call this 1a. That's equation 1a. Now, when I'm doing the elimination method, I'm going to write the second equation down here just to show you guys. 41, this is equation 2. When I'm doing the elimination method, what I want to do is I want to either add or subtract my two equations based on the sign of the coefficient of the matching coefficient. So what we want to do here is I want to look at the matching coefficients. Here I've got 10 and it's a minus 10. Here I've got a plus 10 for that second equation. So the trick here is if the signs, if they are different, what you do is you add the two equations. But if the signs are the same, we subtract. So if you have a look here, are the signs different or the same? They're different. So what I'm going to do is I'm going to add the two together. I'm going to go 1a plus 2. And when I'm doing that, I'm going to look downwards. I'm going to look at each of my sections. So I'm going to look at these x terms. Then I'm going to have a look at these y terms. Then I'm going to have a look at the numbers over here by themselves. So let's have a look at the x terms. When I add the two together, what I'm going to get? 8x plus x is actually just going to give me 9x. Now in the red box, I've got negative 10y plus 10y. When I add those two together, they will just cancel each other out, and so I'm left with no y's. Okay, cool? And finally, in the orange box, I've got 4 plus 41, which gives me 45. And so if I'm solving here, all I need to do is I've got x is equal to, I divide both sides by 9. I've got x is equal to 5, which is exactly what we found with our substitution method. We got x is equal to 5, which is what we had over here. Okay, now that we've done that, I'm going to solve for y. And so what I do is I substitute my x value into one of my equations. So here I'm going to go, well, let's sub x is equal to 5 into, you can pick any one. I'm going to do it into equation number 1. So equation number 1 was 4x minus 5y is equal to 2. So 4x just becomes 4 times x is 20 minus 5y is equal to 2. Okay, I'm going to rearrange. So I've got negative 5y is equal to negative 18. So what I've done here is I've moved the 20 from the left-hand side over to the right-hand side. And so by doing so, I subtract. And so therefore, y is equal to 18 over 5. And we've got our same final answer that we did in the first one. So this was example question 3G. So here I used both the elimination, I used the substitution method, which is the method that we first used and the question asked you to do. But from my own preference, I would probably use the elimination method just if I was to look at this question by myself. Okay, so that was the first question that was submitted to us via Google Classroom. Thank you, Alex, for your submission. Hopefully this video helps you. Okay, I'm going to move on to the next one. Now, someone else, I don't remember who, I'm so sorry, asked a question about this one in 4B, and they had to use the elimination method. They used the elimination method here. So I've already gone through an example of the elimination method. What we're doing is you're either adding or subtracting the two equations so that you eliminate one of your pronumerals, and by doing so, you solve for the other one. Now, if you have a look here, the pronumeral that we select to eliminate is the one where you've got either the matching coefficients, or you can make the coefficients match by doing an easy multiplication. Let's have a look here. Both my x terms have a coefficient of 2. So I'm going to eliminate the x's. My aim now is to eliminate the x's. What I need to do after that, I've checked, let me try that again. Now that I've selected the x as my term that I'm eliminating, because I've got the matching coefficients, I want to check the signs in front of them. In the first equation, what's the sign of the 2x? Well, the sign is a positive 2x. It's positive 2x. So I'm going to write a plus sign there. You don't need to write that in your own steps. I'm just writing it there just to highlight this. How about the second equation? Well, you don't have a negative sign, so this also is a positive 2x. So we have a look. The signs, are they the same or different? They're the same. So if they're the same, what this tells us is that we need to subtract the two equations. So what I'm going to do is I'm going to subtract the two equations. I'm going to go 1 minus 2. Now, if you remember, as I did before in that first example, what I'm going to do is I'm going to subtract them section by section, if I can find the final color. Section by section. I'm going to go down the x terms, I'm going to subtract the 2. I'm going to go down the y terms and subtract the 2. And I'm going to go down the numbers and also subtract the 2. So let's do that. Let's have a look at the green box. My 2x minus 2x, they will cancel each other out. I'm not going to have any x terms. Okay. How about my y terms? So here I've got plus 3y. I'm going to be minusing 7y. I think this is where the question came up. I've got 3y minus 7y. This will get me negative 4y because it is the order that we actually wrote this subtraction. I'm doing 1 minus 2. Here, have a look. I'm doing 1 minus 2. Because it's 1 minus 2, I'm going to do the top equation minus the bottom equation. So that's why it's going to be 3 minus 7, which is negative 4. So 3y minus 7y, which is negative 4y. In the same way, I'm going to do the same with the numbers in the orange boxes. Just remember, I'm doing 1 minus 2. So here, it's going to be 16 minus 24. 16 minus 24. So that's going to give me negative 8. Negative 8. So just remember which order you're doing your subtraction in. Are you doing 1 minus 2 or 2 minus 1? The order matters with your subtraction because it affects which one is being subtracted from the other. Okay. So now that we've got that, let's do our next step. So next step is we just divide by the coefficient of the y term. So I'm going to divide both sides by negative 4. So here, I'll just write the step. So I'm going to divide by negative 4. And so what I get is y is equal to 2. Okay, so for this first one, I've got y is equal to 2. I'm going to flip back to my notes just to check. Okay, cool. Now that I've got that, what do I need to do when I'm solving simultaneous equations? I need to sub my y value, y is equal to 2, into any one of my equations. I can pick either one. I'm going to do it to number 2 this time. So I'm going to substitute it into number 2. So I've got 2x plus 7y. So 7y just becomes, well, if I substitute 2, 7y just becomes plus 14. And that is equal to 24. Okay, I'm going to solve for the x now. So I'm going to move this plus 14 to the other side. So we get 2x is equal to 24 minus 14, which is 10. So therefore, x is equal to, I'm going to do the division step here. So I'm going to divide by 2. X is equal to 5. Okay, so I'm going to do a summary at the end. Therefore, x is equal to 5 and, so this is simultaneous, so they happen at the same time, and y is equal to 2. So that's my solution to this question here. So I think the key question was, is it 7x minus 3y or 3y minus 7x? So that all depends on what order you're doing the subtraction with. If you do it the other way around, if you do 2x minus 1, 2 minus 1, equation 2 minus equation 1, it will be 7y minus 3x. But here I wrote it as 1 minus 2, so I need to keep the order correct. You need to keep the order correct based on what subtraction or addition you were doing. Hopefully this was helpful for you and you could see how we did this question here. Okay, so that was question 4b. Now I have a couple more questions and let me just check. I actually have three more questions to go through. So this might be a bit long. I'm going to put in timestamps so you can link it nice and quickly. So let's have a look at the next question. Question number 5. I think this was submitted by, I actually don't know. Oh, I can get this up. Let me just check. Ooh. So this was, actually it doesn't really matter that much. This was another question that we got submitted in question 5, and I think the person who submitted this said that they had a few difficulties with question 5. That is totally fine. Let's have a go at this. Now I think question 5 told you that you needed to use substitution to solve these questions. So let's have a go at question 5a. This is the first one that we had a look at that is in that set. And they ask you to use substitution. Now, when you're using substitution, just remember, we want to have one of our equations in the form y is equal to ... or x is equal to ... Now, I said one of them. You can actually have both of them in this form, and it will actually still be fine, which is what you notice here. Both of my equations have y is equal to some expression of x. So I can deal with them both equally. Now here they asked us to use substitution. So what we're going to do is I don't need to rearrange any of my equations. I'm just going to sub 1 into 2, for example. So what I'm doing is in the second equation, wherever I see y, I'm just going to replace it with 2 minus x. So here, let's do that. So here in the second equation, I have y is equal to x squared. So if I substitute y is equal to 2 minus x, I'm just going to get 2 minus x is equal to x squared. 2 minus x is equal to x squared. That's just me substituting this 2 minus x into this value of y here. Okay, now that I've done that, I need to solve this. Now, we've done solving questions like this. When we were solving quadratics, we did these types of questions. If you remember, the first step that we need to do when we're solving these questions is to move all my terms onto one side. So I have x, thus the whole expression is equal to 0. I'm going to move everything to the right hand side. The reason being is if you notice, my x squared term is positive here. I don't want to do anything additional with my x squared term. I'm just going to leave it over here. So I'm going to move everything over to the other side. I'm actually going to swap the two sides. So if you get a little bit tripped up, let me know. Here I'm going to have x squared. Now that minus x, when I move it to the other side, becomes a plus x. So this is the minus x, and it's become a plus x. And here, this is a plus 2. So if I move it to the other side, it becomes a minus 2 is equal, and that's all equal to 0 because we've moved everything to the one side. Now, when we're solving this, what is the following step we need to do? We need to use my favorite F word, factorize. We need to factorize this expression on the left-hand side. So if you have a look here, I've got x squared plus x minus 2. I want to find two numbers that add together to give me 1, which is my coefficient of my x term, and multiply to give me negative 2. Now, we've done a bit of practice on this, and what I'm going to do is I'm just going to give you the solution here. I'm going to get x plus 2, x minus 1 is equal to 0. Okay, I factorized it. What do I now do? If you remember, I solve each one of these factors separately. So I'm going to solve this first factor. And so it's going to be, this one is going to be x plus 2 is equal to 0. I'm going to solve it that way. And I'm going to solve this second one. I've got x minus 1 is equal to 0. So from here, I'm going to get x is equal to minus 2 and x is equal to 1. So therefore, I'm going to summarize here. X is equal to minus 2 or x is equal to 1. I'm just going to write a nice, neat summary statement at the end here. Now for this question, because I've got two values of x, I'm going to actually have two sets of solutions here. In the previous examples, so in this example here, I had one set of solutions. So this is just one solution. I've got one x value and one y value that work together. In the previous example, I've got the exact same thing. I've got one x value and one y value. For the question down below, we've actually got two sets of values because I've got two x values here. They're going to have equivalent y values. So I'm going to actually need to substitute both of them back into one of my equations. So let's do that. So I'm going to go sub x is equal to minus 2 into 1. So when I substitute x is equal to minus 2 into equation number 1, I'm going to get y is equal to 2 minus negative 2. So y is equal to 4. And so we've got one set of equations. So therefore, x is equal to negative 2 means that y is equal to 4. That's my first equation solution here. But not only that, we also need to sub x is equal to 1 into my equation as well. So I'm going to substitute into 1. So I'm going to get y is equal to 2 minus 1. So y is equal to 1. And so we've got our second equation solution. So we've got x is equal to 1, y is equal to 1. So usually when I write this, how I do this is I go, okay, I'm going to put this into one big sentence or one big statement. So I'm going to write, therefore, x is equal to minus 2, y is equal to 4, or x is equal to 1, y is equal to 1. And so that's my final statement that I'm going to have and final answer to this question. So here for this question, what we needed to do was we needed to substitute one of my expressions or one of my equations into the other one, just like we've been doing for all the other past questions. But here it was a little bit tricky because both of them were in this form here. They were both in y is equal to. So don't let that trip you up. You can still do that substitution step. The other reason why this was tricky was because it was a quadratic, and when we're solving quadratics, we need to use all the skills that we've been looking at so far with algebraic techniques. We can't just go like, oh, I've forgotten all of that, we don't need it. Yes, you do need it because you need to be solving these questions using those skills. So when we solved it, we ended up getting two answers and for x, and because we've got two answers for x, we're going to actually get two sets of solutions as we've seen in this last bit here. We get two sets of solutions and we need to find each one of them separately. So we need to substitute x is equal to minus 2 and also substitute x is equal to 1 into our equation. So we need to do both of those substitutions, not just one, but both of them. So that was question 5a from the question set that I gave you. Now the person who submitted this also said they needed a bit more help in this question. So I've chosen the first question, and I think I've also chosen the last question to have a go at. And so here, this is 5f. 5f gives me this set. These sets of simultaneous equations. I've got 3x plus y is equal to 9, and I've got x times y is equal to 6. Now here, they're still telling us to use the substitution method, I believe. You're still wanting to use substitution. Now, when we're using substitution, just remember we want y is equal to or x is equal to. So what we need to do first is we need to rearrange one of my equations first. Now, you can actually rearrange both of them. Both of them will have their own difficulties, but you can rearrange either one of them. What I'm going to do is I'm going to do the method where I rearrange equation number 1. Rearrange 1. Now, if you have a look at equation number 1, there's a term which I'm going to make it the equation 1 in make the subject of in this equation. Hopefully you notice that I'm actually going to, and you can probably figure out that I'm going to make y the subject of this equation because it's all by itself, all nice and alone, like we should be in this quarantine, and we already have, so we can easily get it into this form y is equal to. So let me do that. So when I do that, I'm actually just going to move this 3x or plus 3x to the other side. So when I rearrange 1, I'm just going to get y is equal to 9 minus 3x. I'm just going to call this equation 1a. Okay, so I've rearranged equation number 1. I've got y is equal to 9 minus 3x. Now that I've done that, when we use the substitution method, we substitute this equation over here into the other one. So what I'm going to do is I'm going to substitute it into the other one. So wherever I see y in equation number 2, so I'm going to go sub 1a into 2. Wherever I see y in my second equation, I'm just going to substitute 9 minus 3x. So here I've got xy. Just a reminder, if you see xy, what does that tell you? xy is the same as doing x times y. X times y. So here I'm just going to go x times, or I'm going to write a bracket, and I'm going to put this substitution in, this blue box, 9 minus 3x. And that's equal to 6. Okay, now that I've done that, I'm going to solve this. Now, this will actually give you a quadratic, so we need eventually. But if you have a look, we've got that bracket. I don't like dealing with that bracket. Let's get rid of the bracket. So let's do that. So I'm going to expand out the bracket. So when I expand out the bracket, I'm going to get 9x minus 3x squared is equal to 6. Now when we're solving this, we want to have the x squared term to be a positive usually. So I'm going to move everything on from my left-hand side to the right-hand side, but I'm just going to rewrite it as positive on the left-hand side because I don't want to bother doing that additional step. So here I'm going to change my 3x squared to a positive. Because I've done that, the positive 9x here is going to become a negative 9x. So I'm going to have minus 9x. And because I haven't moved that 6, I'm going to just do plus 6. So what I've done here is so in the case you're wondering, what I've done is I've moved everything to the right hand side, but then just swapped the sides. I'm lazy and I don't want to write in additional steps. I apologize. Okay, so I've got this equation here. And then we want to solve this equation. So if you have a look here, you can probably go like, oh, it's a non-monic quadratic. I'm going to do that grouping method and solve it by using, factorize it by using grouping. But before you even do that, I'm going to recommend that you have a look to see if you can factorize out any numerical factors. If you have a look at my algebraic equation here, 3x squared minus 9x plus 6. All of them have a factor of 3. So what I'm going to do first is I'm actually going to factorize out the 3. So I'm going to go 3x squared minus, I'm going to take out that 3. So I'm going to get 3 bracket x squared minus 3x plus 2 is equal to 0. And if you have a look at the thing inside the bracket, that's actually a lot easier to factorize. We've done factorizations like this. So I'm just going to factorize it. So I'm going to get 3x minus 2, x minus 1 is equal to 0. And like we did before, we're going to solve each one of the factors separately. So I'm going to go x minus 2 is equal to 0, or x is equal to 2. And I'm going to go x minus 1 is equal to 0, or that gives me x is equal to 1. So here, just like that previous question, I'm going to get two solutions. I'm going to get x is equal to 2 or x is equal to 1. Now what I need to do, like the previous question, I'm going to need to substitute those back into my original equation. So any one of them will work. So I'm going to actually substitute it into 2. So I'm going to go sub x is equal to 2, which is the value that we found at the bottom here, into equation number 2. So if you have a look at equation number 2, I have xy is equal to 6. Xy just means x times y. So here it's going to be 2 times y is equal to 6. So y is equal to 3. Okay, so I have my first set of solutions here. I'm actually going to write it at the end so it saves me a bit of time. Then the next bit is I need to substitute x is equal to 1, which was the other value I found. So I did the x is equal to 2. Now I need to do the x is equal to 1. And so I'm going to substitute x is equal to 1 into 2 again. So here, if I substitute x is equal to 1, I'm just going to end up getting y is equal to 6. Nice and easy, because I have x times y. If x is 1, we just have y by itself, so I have y is equal to 6. Okay, cool. So to summarize, therefore, my solutions are x is equal to 2, and when x is equal to 2, what is the solution? When x is equal to 2, the solution is y is equal to 3. So I'm going to write that in here. Y is equal to 3. Or when the other solution was x is equal to 1. X is equal to 1, and when x is equal to 1, what's the solution for y? Y is equal to 6. So here for these equations, you're actually going to get two sets of solutions for these equations. And there's actually a reason for that, but we'll go into that a little bit later when we maybe draw quadratics. So this was question 5F. Hopefully this was helpful, and in particular looking at these last two questions. These two questions were in fact a little bit trickier and require you to think a little bit more. Have a go at the rest of those question 5 questions and use these types of skills that you used, and have a go at that. Now, I do remember I made a note at the beginning that for this question, I could actually rearrange either one of my equations. So I'm going to just make a note over here. I can actually rearrange equation number 2 to make it in terms of y or x. So what I'm going to do is, if I want to make this in terms of y, originally I had x times y. So if I want to have y by itself, what do I need to do to both sides? Well, if I want to get y by itself, I need to divide both sides by x. I need to divide by x. So here I can rearrange equation number 2 and it will actually get me 6 over x. This would give me this will end up giving me the same answer. It's the same solutions in the end. But for this part, what you'll need to do is when you substitute it into your first equation, you need to multiply all the terms by 9 to make it a little bit easier. So you can actually rearrange either one of the two equations. They'll both give you the same answer in the end. So that's question 5F. Okay, there was one more question that was submitted, and I do remember, I think Marianne suggested this. So thank you for your submission, Marianne. And this is question 6D. Question 6D. And this was one of those worded problems that we had at the end of that question. Now, when you do worded problems, whenever you see a question like this, or you see questions where it's like you have words and you're like, oh, I don't see any math there. Slow down, chill. What you want to do is you want to break down the question. So when you're doing these, and maybe I'll make a note of this in a future lesson, because I think there's a few topics later on where we'll need to do this. When you're doing these types of questions, there's a few steps you want to do. You want to introduce your pronumerals. So for these questions, we have an unknown. We don't know how many, if you read through the question. So let's actually read through the question. That's a really good first step that we need to do. So twice as many adults as children attended a certain concert. If adult tickets cost $8 each, child tickets cost $3 each, and the total takings were $418, find the number of adults and children who attended. So if you have a look here, that we want to find the number of adults and children who attended. I'm going to do a Newman's, and I'm actually going to go through and underline the key information that we want to do. So here, what I'm going to do is I'm going to go, okay, well, there was twice as many adults as children. So I know that number of adults was 2 times as many as children. The next most important information is that adult tickets were $8 each, and then children tickets were $3 each, and the total takings were 418. Okay, so that's all the important information, and we actually want to find out the number of adults and children who attended. Now, what I wrote down was we want to introduce pronumerals. So these usually represent your unknown values. Unknown values. So here, I don't know the number of children, number of adults, or the number of children. I don't know what they are. So I'm going to introduce 2 pronumerals to represent them. So here, you could use whatever pronumerals. You could use letters. You can be like A, B, C, or like X, Y, whichever ones you like. Or you could be fancy. Now, this is just joking around, but you can use like symbols if you wanted. I can be like, oh, let apples represent parents, and windows represent children. You could totally do that. This is just taking it too far. So stick with this stuff. It makes it a lot easier. Now you can use whatever letters you want. Just to make it a little bit clearer, I'm just going to go here. I'm going to go let A, so we want to find the number of adults, be the number of adults. And C be the number of, what do you reckon C would represent? Yes, it's the number of chickens that were there. No, it's the number of children. Number of children. Okay, now let's go through the question and use all the information that we have. Now, if this is in the section on simultaneous equations, that's a big hint that you're going to end up using simultaneous equations. Wink, wink. Now, let's start from the top. First part we read through. Twice as many adults as children attended the concert. Okay, so what does that tell me? Well, twice as many adults as children attended the concert. So what this means is, well, the number of adults that were there is actually 2 times the number of children. I can write this as an equation. So what I can do is I can go, well, the number of adults was twice as many as the number of children. That's 2c. So this is the number of people. That's the first fact we used. So twice as many adults as children attended the concert. So the number of adults was twice the number of children. The number of adults is just 2 times c. So A is equal to 2c. That's my first equation. I'm going to write 1 over here. What's the other piece of information? If adult tickets cost $8 each and child tickets cost $3 each and the total takings were $418. Stop there. I know adult tickets cost me $8. Children tickets cost me $3 and the total amount is $418. I can create an equation for that as well. Now, when you have those tickets, you add them together, and what's the final amount that we're going to get? So we're going to have the final amount in this part is going to be equal to $418. Now, let's just break it down. How would I know how much I would make off the adult tickets? So each one is $8, and I don't know how many adult tickets there are. So if there was 1 adult, I would only get $8. If there were 2 adults, I would get 8 times 2, which is $16. If there's 3 adults, I'll have 8 times 3, which is 24. So if I want to write the adult tickets section, what I do here is, well, I go, okay, cool. I know that for every adult, it costs $8. So I'm going to write it as 8 times A. Because for every adult, it costs $8. For every adult, it costs $8. So for this first part, I'm going to have 8 times A. In the same way, how would I write the children tickets information? Well, each children ticket cost me $3. So what I'm going to have is I'm going to add on top of that 3 times C. Because every time I got a child ticket, it cost me $3. So this is the cost of tickets. So I'm going to call this equation number 2. Now, if you have a look, we've got 2 equations. What method do you reckon we can use to solve this one? Yeah, I'm going to use substitution method. Here, if you notice in the first equation, I have A by itself. I have A by itself, and it's the subject of the equation. So what I'm going to do is I'm going to go, well, let's sub equation number 1 into 2. So every time I see A, I'm just going to replace it with 2C. So let's do that. A is equal to 2C, so I have 8 times A. 8 times A will actually just give me 16A because I'm just multiplying 8 by 2C. Oh, and it's not A, it's actually C. Plus 3C is equal to 418. I'm going to solve this, so and I'm going to end up getting 19C on the left-hand side is equal to 418. So the number of children there were is 418 divided by 19. Now you can chuck this in your calculator, and you end up getting 22. Now you can check this. A reasonable answer if you want to check. It's a number of children. Usually this answer won't be a fraction. If you did get a fraction, you'd be concerned. So this answer seems legit. Okay, cool. So I've got C is equal to 22. What do I need to do from there? Well, I then sub C is equal to 2 into one of my equations. I'm going to sub back into 1. That's the easy one to do. So I'm going to get A is equal to 2 times 22, which gives me that the number of adults there were 44. So when you're done with a question like this, writing A is equal to 44, C is equal to 22, that might work. But usually if you have a worded problem, you want to write a worded solution at the end. So here, let me just summarize it here. So therefore, there were 22 children and 44 adults at the concert. Okay. And with that, we're done with this question. So with these ones, you just need to make sure that you read through the question very carefully. Make sure you note down all the important information. Underlining it is going to be really helpful here. And then you just want to, the main important step after that is then you want to introduce your pronumerals. You want to go, okay, let letter be equal to one of your unknown values. So here I let A be the number of adults and C be the number of children. And I worked off my information that I had in my question to build these two equations and solved it simultaneously. So that was the last question I got asked about in the simultaneous questions section. Hopefully this was helpful and answered your question. Continue posting your questions up on Google Classroom. I'm more than happy to create a video like this to help answer your problems. There's also the Google form. Post it up on there or send me an email. So yeah, I hope you're doing well, Year 11s. And as always, stay safe, stay healthy, stay wonderful. Take care of yourselves, Year 11. I'll see you around when I see you.